Hello and welcome back to the lab. Today on the bench, I have a stack of scopes. These were sent to me by a viewer of the channel who asked if I would take a look at some of these and see what I can do about getting them fixed. From what I have been told, there is two more that I don't have, and they are in various shapes of condition and also of various models. We have some 475s. We have a couple 475As, so some of them have the piggyback meter, some of them don't. I have notes on some of them about power supply, potential power supply rail problems. Looks like this guy is going to have some negative 15 volt problems, 12.801, so that's going to be a problem, and we'll have to look at that. But, yeah, I was asked if I would give a 475 the treatment, and I hadn't done that yet on the channel. So I now have some 475s to work on. So let's get one of these cracked open. We'll start with this 475A. I have a sneaking suspicion this one's going to be in the best condition. It has the... Oh, yeah, this one's in really nice physical condition, just from what I can see so far. Oh yeah, that is in almost immaculate condition. So let me get the bench cleared off. We'll put this one up on the bench first, and we will see what we can do. All right, let's take a look at this 475A. We have property of IBM. How do we look on the back? The accessory pouch is in reasonable shape. Nothing in it. We have a busted foot, so we'll have to take care of that. Fixed power cord, regulators on medium setting. That really needs to be, this really needs to be bumped to high. So we'll have to print out a foot, actually 2 feet. Actually, it looks like this one already has one 3D printed foot, but something happened to it. But that to make that 2. No, it has 3 3D printed feet. So these 2 are okay. This one's needed. That one's needed. Scope is in wonderful condition. We actually have a tagged IBM on there, so all the knobs look good. This is a little strange. Was this an IBM special order? The delay time position knob is not quite right. I don't have any others that are IBM based, but yeah, it's the right potentiometer that's in there, at least by feel, but it is certainly not the Tektronix delay time knob. Have to see what the shaft is like on that. I might be able to dig up a delay time pot. Actually, on this one, the controls feel very good. Nothing's too stiff. Yeah, all this is a little bent, but nothing horrible. Everything from a life standpoint, this guy was well kept. How do we want to start? So we have a DMM up on top, so we'll have to I'll have to align the DM44 as well as the scope when we go to do the alignment, so we'll have to break this out. I do have all the stuff in the lab to align a multimeter, except on this one I don't have the temperature probe, so I will have to see what we can do about that. Other than that, it looks okay. Let's crack it open and just take a quick look at the inside, see what it looks like. Well, here we are inside. One thing I did notice is this is a mod PG. Gonna have to look up what that modification was. I don't know off the top of my head. But this is the one that supposedly has some power rail problems. So this is a switch. I don't want to say nightmare, but it would definitely be interesting. This is a lot of switches that are known to have problems on some of these scopes. So these could definitely cause some issues down the road. Other than that, it looks pretty close to a straight 400 series with the piggyback DMM. So power supplies here, transformer bulk filters, tubes obviously in the middle. Vertical board, trigger board. I'm sure the power supply board is going to be on the bottom, as per usual with one of these. Yep. Rectifier's high voltage supply. Let's take a look at the attenuator board. Haven't seen inside a 475 yet, but ooh, nice heatsink. Move you guys up. Give you guys a bird's eye view as to what's going on. Finger switches per normal. Custom tech IC. I bet you, yep, those finger switches are for the bandwidth limit. And trigger view, another custom tech IC. I do not know if this is early or late production. I haven't seen any boards yet. This is more of the custom tech ICs I'm used to, not these big cans. Very standard attenuator configuration for a Tektronix scope. This is no cleaning. I haven't done anything to this. This is just how I open a box. So this is immaculately well kept for its age. What's my serial number? 14999, I guess. So, well, we'll have to get started. Okay, I have the power supply hooked up to some, or I have the couple of meters hooked up to some power supplies of interest. I have the scope hooked into my power analyzer, and I'm going to power it on and see what's going on. I know it's been powered on recently because of the list of voltages that have been on it, so we'll see what happens. Keep an eye on that for me, and here we go. Yep, 5 volts, minus 5, let's see, plus 5, plus 15, and we're at 12.81. So that confirms we're also drawing quite a bit of power, 902 milliamps, so 89 watts. And that is with the regulator set to the high setting. Okay, so, oh, there it goes, came back. Okay, so I had intensity and then it came back. Tube is very healthy. But now we're having some problems. That's on ground. All this is set right up. I am actually triggering on something. I have no idea what. But let's turn that off so it's not triggering on anything. I think our power draw may be in the DMM. But we also have some tube problems. Interesting. Let me hook the meters back up. Well, injecting negative 15 volts with 10 milliamps of power lets the voltage build to negative 15 volts. So I don't have a short on the rail. I also measured the resistance. It was like 11K ohms. So I don't have a short on the rail. So do I have a crappy rectifier? This guy. has cost me an evening. Holy crap. But I found it. Let me get the bench cleared off. I'll print out a schematic, and I will show everyone what the nightmare that I have been fighting. Never would have guessed. Never would have guessed it was that part. Never. Okay, let me sit down with a pointer and we will dive into this. I have spent a couple of days on this. Well, 2 days on this, last night and tonight, trying to get this 12 volt, or this 15 volt, negative 15 volt rail working. And this thing has been a pain in the butt. So this is an abridged copy of the negative 15 volt rail. It has its own bridge rectifier, which is here. We have this filter capacitor, which is here. As you can see, we have new solder. Yeah, there's a reason for that. So we have bridge rectifier. We have the negative 15 volt test point. But then all our regulation for this power supply happens down here. So the op amp in question is down here. We have a couple of resistor, these 3 resistors, this resistor, this transistor, that transistor, and a few other things. I think these 2 resistors go into the negative 15 volt rail. This is the main pass element with the heatsink. That is officially Q1478. And so, wow, what do we got going on here? So, as we tested before, this power supply was at 12 volts, negative 12 volts, and it was not coming up. The weird thing was it wasn't tripping the overcurrent on the power supply, and it also wasn't blowing the fuse. So I started the troubleshooting process saying, okay, it's probably not shorted. There's also a ohmic troubleshooting in the service manual that basically says ohm out the power supply from the test points, and I was getting a reasonable reading on that, very close to what I was supposed to get. So at least when it was off, everything was good. So what I also did was I did some voltage injection at 100 milliamps of current, and I shot negative 15 volts into the 15 volt rail with the scope off at 100 millivolts. Bang, negative 15 volts. So that confirmed that I was not looking for a shorted tantalum or anything like that. The rail was not shorted to ground. Both ohmic and doing voltage injection proved that. So we were not dealing with a shorted rail, nor were we dealing with a partially shorted rail, because at 100 milliamps of current, I should have seen some voltage drop if the rail was pissed off. And no, it just, power supply went to negative 15 and we were good to go. After poking around a little bit and reading the circuit description, we have 2 pass elements that do the regulation. And then we have an error amplifier, which is the B portion of the op amp in this package right here. So before I had schematics and everything like that last night, since I have so many more 475s, I just pulled the IC, swapped it out, and rail didn't change. Nothing. So I was like, okay, and these 2 transistors were socketed, so I pulled them out and I checked them on my Atlas DCA Pro, just a quick transistor checker. Both of those checked out and were showing reasonable values for what they were. And I just compared them to another scope, and I mean, HFE was off by like 10. So I was reasonably sure those were functioning. So this resistor was of interest to me, so I checked that. It was reading a little high, but not high enough to cause any kind of problems or anything like that. The op amp was fine. The rail was fine. And so I was arguing with it. Still 12 volts, 12 volts, 12 volts. I even suspected the bulk filter capacitor, because I was getting 12 volts at the bulk filter capacitor too, which was odd. So it wasn't like I had a higher voltage here and it was bad at the test point. Of course, the test point is on the bulk filter capacitor, so that wouldn't be a problem. So I almost suspected the bridge rectifier, maybe CR1472 is bad. So I stripped the scope down, pulled this board out, pulled the rectifier off, which you will all notice that there is no room to get at it under here. So I had to pull this capacitor out, that capacitor out, rectifier out, tested the rectifier. Rectifier's fine. I also did an AC check at the transformer windings just to make sure I had AC, and I was getting 25 volts of AC there. So I thought maybe the rectifier had a issue with it, and it wasn't outputting, like maybe one of the diodes had failed and it was only doing partial rectification. Still no dice. Rectifier checked out okay. So this transistor's checked okay, that transistor's checked okay, this op amp's checked okay, the rectifier's checked okay, the capacitor's checked okay, this capacitor was also checked, it's fine, and everything's working. The scope's even showing a trace. It's just going kind of blinking in and out, so I might have to do some high voltage troubleshooting. So it's like, okay, something's still not quite right. So I pulled out another scope, pulled out the power supply, and I was doing voltage comparisons between just different points in the circuit, and everything's really close. I mean, we're talking like within a millivolt or something like that, like 2 or 3 millivolts. And I'm comparing resistance measurements to all these parts, and everything's real close, real close, real close. Right before I hit it, I flipped my meter leads because I was measuring the resistors with negative on ground and then positive going in. Well, I flipped my meter leads, and all of a sudden, this part right here, which is R1474, showed bad. So what ultimately ended up happening is we have a voltage divider here which references the positive input of the op amp to the negative 50 volt rail, or the positive 50 volt rail, sorry. So we have the 15 volt sense lead coming through 1475, which is the 15K, being summed against the 50 volt rail, because that's the main reference of the scope, into this node, into the op amp to drive the transistors. This is a very precise, I think it's a 1%. Let me look at it. It might be even more precise than that, but it's supposed to be 50K very precisely. Okay, I did check. This is a 0.25% 50K ohm resistor. So this is a very, very precise resistor in this voltage divider. Let me hook it up to the meter and you guys can see for yourselves. I don't think we're hitting 0.25% with a 58K ohm resistor. That's 8,000 ohms higher than it should be. So one of the reasons this was such a pain in the butt to troubleshoot is those precision resistors from Tektronix usually don't give too much of a problem, and they usually hold their value very well, especially with the condition of the scope, how well it was kept, and everything like that. It would not have been my first culprit for something like that, especially with how good this scope looked. But that resistor went out to lunch, and for being as precise as it's supposed to be, it went into orbit. Well, I'll just turn the scope on and show you. Powering up the scope now. 15.00. So we are good to go on at least that problem. Now, here's the real question. Did it fix any of the... No, it did not take care of the DM44. So this is going to be the gift that keeps on giving. Well, we'll just see what it does and go from there. I got to check the controls now that the power supply is back to rights, and I'm going to spot check the other supplies just to make sure we don't have any other problems, and then we can move on to some of the more troubleshooting. I really hope I don't have to get into the DMM44's power supply in this thing, because taking the trigger board out was fun to get to the capacitors. That one's not horrible. Digging that power supply out is going to be a nightmare. Okay, so after buzzing through a lot of the 74 series logic with the Tontek IC tester. All the 74 series logic is testing good, which means we either have signaling problems, socket problems, or custom tech chip problems. So I still need to do some more troubleshooting. I did hook a scope up to points of interest on the DMM44, and I did find we have clock. So we at least have partial clock, maybe not all clock, but for some reason it's just not updating. Nothing changes the display. So still a bit of an argument, but we'll see what's going on. Okay, let's see if we have solved the problem. Well, I'd say that's looking healthier than it was before. Let me show you what I found. All right, aside from the, turn this off so I don't short anything out. The Tech IC, the TI sockets that are in this unit, there are two custom Tech ICs that are the heart of the unit, and there's also a misprint in the manual. So we have this one right here, yes, which is U3340 right here. The IC number is an LD110CJ. If anybody knows a cross-reference part for that, please let me know. I'd like to order some. We have the exact same IC right here, actually with a funny pin position, so it's bent out. This particular version of that IC was toasted out, and that's why the meter was locked up. The manual calls out if the meter's doing something. The flowchart in the manual says, look for U3163. It's not 3163, it's 3165. So that is a correction for the service manual for the DMM. But we have the DMM back. Now all it needs to do is a calibration and a full check-in before it's all said and done. So what I have to do now is I need to service up these attenuators, get them all squared away, set to go, and then we should theoretically we can try aligning this. See how it goes. For these units, after working on a DMM, I was thinking about adding a DMM 44 or 43, 44 or 34 to the collection. I think I prefer the standard non-DMM scopes, especially with the difference in the delay time position. I'm leaning towards the more traditional delay time position knob, especially knowing that if the DMM ever goes bad, there's problems in the horizontal sweep section. So, and the DMMs do have quite a few custom Tech ICs that are on the more sensitive side. So yeah, let me get these covers off, and then we'll service up the attenuator and go from there. Okay, one thing to note, this happened in one of my 7A 26s that I had, is there's a couple of resistors right here. They're very small, 1/8 watt or 1/16 watt resistors. These are part of the attenuator networks. If the attenuator gets catastrophically overloaded by a surge or something that's being measured, too strong a signal, I've actually seen some of these resistors actually burn in half. So one's hiding out right there. And when that happens, they'll be replaced. Now, the weird thing about that when it happens is because it's still really close together and touching, there's still a capacitive coupling effect at high frequencies. So it makes the waveform on the scope look very strange. But the channel's not completely dead, but it's definitely not normal. And so you can also check these resistors. Some of the attenuator networks have them soldered in. Some of the attenuator networks, they're in sockets. I do have some repairs on the 7A 26s coming again with the overloaded front end, but that is also something to watch out for. So I've gotten these attenuators serviced up, and these are ready to go. So I'm going to put the covers back on here in a little bit. I got to move the knobs a few more times, but then I got to put the covers back on, and then we'll just test it out and make sure it works. All right, I've got some signal put into the front end. And let's see if we get anything. This is good. We have a display that's working now. Let's see how this goes. But this isn't healthy. And I'm not triggering on anything. Well, that's bad. Alright, let's take a look at my trigger board real quick. A reseat of the trigger trips seems to have brought the trigger back. So I'm going to let this run for a while just to make sure we don't have any other problems. I have a sneaking suspicion the TI socket over here is having some issues. So if I have to pull that apart again, I will... I'm going to just let this run. And if I have to pull that apart again, I will be replacing that socket. But as of right now, seems to be all right. Turn this off. I can tell it's still triggering by the lamp. As long as that stays lit and the numbers are good, we should be good to go. But as long as that doesn't lose trigger for a while, I'll put the covers back on, and then I think we may be able to start an alignment, possibly. All right, as trigger's nice and stable now, everything's good to go. We don't have any noise on the attenuator, which is good. So I can pop those back together. I'll show you the chip of interest just in case the trigger goes a little weird again. Moving over to the right side of the scope, we have this custom tech IC in, yet again, a Texas Instruments socket. The chip's fine. Everything's working. The trigger's working the way it should. It's just... those sockets, which we've been over a few times on the channel. So, I want to button up those attenuators, and then we will see what's next. Okay, that's going to be it for part one. I will be starting the calibrations, the alignment procedures in part two, and probably this will be probably a four-parter as normal. But this one's going to be a little weird, especially when we get into the horizontal position, aligning the DMM along with the horizontal, so those two have to be aligned together. So I have to do the power supply tube and vertical section along as normal would be for a scope, but then when it comes to the horizontal section, I have to use the DMM alignment procedure to align this with the horizontal. I can't use the scope horizontal procedure, so that's going to make it a little bit more interesting. As you guys saw in the intro, I got a few more of these that we're going to have to troubleshoot, or I'm going to have to troubleshoot and go through. Let me know what you guys think in the comments, and I will see everyone in the next video. More's on the way.